Good morning, everyone. Today we are discussing the another type of Laplace transformation, that is second shifting theorem. So this is the second shifting theorem, or we can also say that it is a second translation theorem. Okay. So I already defined the Laplace transformation in before videos, in previous videos. So, and also say that, and also discuss one type of the Laplace transformation. Here we are discussing the second type of a Laplace transformation, that is second shifting theorem. So, what is the statement for the second shifting theorem is Laplace of f of t equal to f of p and g of t. They have given the some condition g of t is equal to f of t minus a. This satisfied only for t greater than a. So that is we are taking the values that is more than a, and uh, that equal to 0 and t less than a. So if we take the lesser values of a, so the value is 0. Then we have to show that Laplace of g of t is equal to e power minus ap into f of t. So let us consider the Laplace of g of t. So definition for the Laplace transformation is integral 0 to infinity e power minus ap into f of t. Here in place of f of t, they have given the g of t, so dt. So we are splitting the integration 0 to a e power minus, sorry, definition for Laplace transformation is e power minus pt into g of t. Laplace of g of t equal to integral 0 to infinity e power minus pt into g of t. Good morning, everyone. Today we are discussing the second type of a Laplace transformation, that is second shifting or second translation theorem. So in before videos, we already discussed the what is the Laplace transformation and what type of the Laplace transformation we can solve. Already we have discussed one type of a Laplace transformation, that is first shifting or first translation theorem. So that is, and the next method and the next type is second shifting and second translation theorem. So here the statement is the Laplace of f of t equal to f of p. Then they have given the condition g of t equal to f of t minus a. So it is satisfied only when we are taking the values for a that is more than values of a. So if you take the values that is more than a, so we get the value function f of t minus a that equals 0 where t is less than a. So we are taking the values for lesser than of the a. So then we have to show that Laplace of g of t equal to e power minus ap f of p. So let us consider the definition. Let us take the definition of the Laplace transformation for g of t. Here, the Laplace of g of t equal to integral 0 to infinity e power minus pt g of t dt. So we are splitting the integration. So that is 0 to infinity. We are splitting to 0 to a minus pt into g of t dt plus a to infinity e power minus pt into g of t dt in place of 0 to a, that is taking the values between less than a. So that is the function is integral 0 to a e power minus pt into 0 into dt plus we are taking the values more than a, so that is a to infinity. So the function is e power minus pt g of t is f of p minus a dt. Okay. So to solve this integration value, that is a to infinity e power minus pt into f of p minus a dt, we have to do some substitution here. So that is p minus a is equal to u. Then t is equal to u plus a. Okay. So you take the derivative. So t with we are differentiating with respect to t. So t with respect to t is 1. So then u with respect to t is du by dt. And constant for derivative for constant is always 0. Then we get dt is equal to du. dt equal to du. If you get take the values for, if you take the values for t equal to a, we get u is equal to 0. If you take the values t equal to infinity, we get u is equal to infinity. Then integration is turned to 0 to infinity e power minus p into t in terms of u. So that is u plus a f of t minus a means we have substituted u. So dt means du. So then next, then we can split the integration, that is integral 0 to infinity e power minus p into, when bases are added then we can split the power. So e power minus pu into e power, in the previous question, so in previous term, so we get e power minus pu into e power minus pa. Okay, into f of u du. So here minus pa is the constant term, so that is why we are taking the outside. So integral 0 to infinity e power minus pu into f of u. This is the definition for Laplace transformation in terms of u. So we have, so e power minus pa into Laplace of f of p. So that is f of t, that is we get f of, okay, e power minus pa into f of p. So finally Laplace of g of t, where g of t is equal to f of t minus a, where t greater than a, that equals 0, where t less than a, we get e power minus ap into f of p. This is the second translation theorem. So now we will discuss one example for second shifting theorem. So find Laplace of g of t, where g of t is equal to e power t minus a, t is greater than a, that equal to 0, then t is less than a. They have given the g of t like this. So uh, when we compare with the second shifting theorem, g of t is equal to f of t minus a. Here f of t minus a is e power t minus a, where t greater than a, that equals 0, where t less than a. So we can let me know that f of t is e power t. So if you give find the Laplace transform for that f of t, Laplace of e power t is 1 by p minus a. First of all, we know learn the all these formulas of Laplace transformation. So Laplace of e power t is equal to 1 by p minus a. Then by second translation theorem, Laplace of, then we have to find Laplace of g of t is equal to e power minus ap into f of p. Here f of p is 1 by p minus, here f of p is 1 by p minus a. Then we can substitute e power ap. So what is the a here? So here also a is only a. So then f of p is 1 by p minus a. So Laplace of g of t is equal to e power minus ap into 1 by 1 p minus 1. Okay. Next. So next theorem, that is change of scale property. So now we are discussing another method for solving of Laplace transformation. So that is change of scale property. So change of scale property is Laplace of f of t is equal to f of p. Okay. Then Laplace of f of a t is equal to 1 by a into f of p by a. Okay, we have to solve this one. Let us consider Laplace of f of a t. So definition for Laplace of f of a t is integral 0 to infinity e power minus pt into f of t. Here f of the place of f of t, that is f of at. So substitute that one. So we have to solve this value. So we have to take the some substitution. Substitute at is equal to u. Then t is equal to u by a. So then take the derivative. So with t with respect to t is 1. U with respect to t is du by dt. Then dt will get cross multiplied 1 by a into du. We get the value of dt. So if you take the values of t 0, we get u is also 0. If you take t equal to infinity, we get u is also infinity. Okay. So then substitute the values integral 0 to infinity e power p into t is equal to u by a, and f of at means f of u, then dt means 1 by a into du. So 1 by a equal to integral 0 to infinity e power minus pu by a. Okay. Pu by a. So f of u into du. So Laplace of f of t is f of t. Then we have here we have e power minus pu by a. So here the variable is u. So the constant is a. So the function will get f of 1 by a, f of p by a. So it will turns to the 1 by a, f of p by a. Okay. So this is the change of a scale property. So now we will discuss one example for this change of scale property. So find Laplace of cos 4t by using change of scale. By using change of scale. If they didn't say that solve the problem by using change of scale, we can easily solve the cos 40. It is only a formula for Laplace of cos 40. So we can easily apply p by p square plus 4 square. But we have to solve that problem in the change of square. So let us consider it is in the form of f of at. Let us consider f of t here. F of t is cos t. Okay. Then Laplace of f of t is what? So we have to apply the formula, that is p by p square plus 1 square. So we have to apply the change of scale method here. So the change of scale property is Laplace of f of at is equal to 1 by a f of p by a. 1 by a f of p by a. That is Laplace of cos 4t, okay, is equal to 1 by 4 into f of p by 4. Okay. So here f of p is p by p square plus 1. So that is 1 by 4 into p by 4 by p by 4 whole square plus 1. Okay. So we get 1 by 4 into, so 4 is also in the denominator. This 4 will also goes to the denominator. Then we get p by 4 into, okay. So take the LCM here, that is 16. P square plus 16. Take the LCM. So 4 and 16 will get cancelled by 4 times. So 1 by 4 into 1 by 4 into this 4 will get numerator. So P 4P by P square plus 16. So both 4 will cancel. We get P by P square plus 16. So by using the change of scale method, so the Laplace of cos 40 is p by p square plus 16. Okay. So two methods will be explained in this video. So hope you all understand with the one example. I also discussed with one example. So hope you all understand. Thank you.